Theorem 12.9, volume of a pyramid is simply the formula 1/3 area of the base times the height, which is the exact same formula for volume of a cone. But once again, since it's a cone, we switch out area of the base with pi r squared because the base of a cone is always going to be a circle, so we can put in pi r squared for area of a circle. And so, first example, we're finding the volume of a pyramid with the regular base. And thankfully, it's a hexagon, which makes it really easy. All right, so first thing we got to do is find the apothem, which remember the apothem is that line that goes from the center straight to the middle of the opposite side. And so since each side of this pyramid is 2 centimeters, that apothem is going to split that side into lengths of 1. And to find the angle there of the central angle, we take 360 divided by 6, which is going to give us 60 degrees for the total angle there. But we only want half of that angle, so one side of that's going to be 30 degrees. And once we've got that, we can look at it as a individual triangle that is a 30, 60, 90 right triangle with one for the short leg. And we're trying to find the apothem, which is the long leg. And the relationship is that the long leg is the square root of 3 times the short leg on a 30, 60, 90. So the square root of 3 times 1, or simply the square root of 3. So we're trying to find the volume, 1/3 area of the base times the height. And so area of the base, since it's a hexagon, is 1/2 of the apothem times the perimeter. So we've got the apothem, that's 1, or the square root of 3. The perimeter, since it's got 6 sides and each side is 2, we're doing 6 times 2, or 12. So for area of the base, we've got 1/2 square root of 3 times 12, or that's 6 square roots of 3. So once we got that, now we plug it into the volume formula. Volume equals 1/3 of 6 square roots of 3 times the height, which is 5. So the volume equals 10 square roots of 3. 6 times 5 is 30, and 1/3 of 30 is 10. So 10 square roots of 3, or we can plug that into a calculator, and we get 10 times the square root of 3 is 17.3, and it's going to be centimeters cubed. All right, so that was the most difficult option for volume of a pyramid, since we had a hexagon for the base. It would have been much easier if it was a square or triangle. But so then from there, we're moving on to cones. We got a right circular cone and an oblique circular cone we're going to find the volume of. And so volume, once again, coming up from the volume of a cone, we're using 1/3 pi r squared h. So 1/3 pi r squared times h. So all we've got to do here is plug in the appropriate values. So volume's 1/3 of pi times the radius squared, 6.7 squared, times the height of 10.2. So 1/3 of pi, 6.7 squared is 44.89. There's 10.2. So plug it all into a calculator. I get 479.5 meters cubed. All right. So the next one is an oblique circular cone, and in this case, the height is going to be the same as the distance of this side of the cone, going straight down to the base, which is 7. So once again, we're using the exact same formula, 1/3 pi r squared h. So our volume is going to be 1/3 of pi times the radius squared, which is 3.1, times the height, which is 7. So volume equals 1/3 of pi, and 3.1 squared is 9.61 times 7. So plug that in. I get 70.4, and the units are inches, so inches cubed. So lastly here, we use the given measurements to solve for x. So they give us the volume 2262, they give us the height of the cone is 15 feet, and we're solving for x, which is the radius value. So once again, volume equals 1/3 pi r squared h. So volume, or the actual value of the volume, is 2,262 equals 1/3 of pi times the radius squared, x squared, times h, which is the 15. So 2262 equals, you can take 1/3 of 15, which is 5 pi x squared, divided by the 5 pi, and 2262 divided by 5 pi gives us 144.0 equals x squared, and then it's just simply take the square root of both sides, and we're going to get 12 equals x, or I should say 12 feet equals x. And that's all there is to it.